Thanks, Jan. So I have the pleasure of talking a little bit about visualization, which is kind of ironic because I'm a sand guy and spent a lot of time pounding the beaches and yet have worked with a core team of, I should say, the privilege of working with a core team of folks within NANOOS who have actually been instrumental in integrating a lot of the different data sets that we have out there and developing the platform that we see today in terms of delivering information to folks. So what I'm going to talk about is a little bit about where we were a few years ago and where we're at today, and some insights in terms of where we might be going down the line in the future. And we've heard so far today that one of the key components of IOOS and NANOOS in general is the acknowledgement that several years ago, a decade ago, access to information was being accomplished through multiple venues, multiple data streams, multiple sites, and to be honest, it was actually, for those who are not well versed in finding information, it's a challenge for folks, particularly the public at large. And so really in terms of trying to integrate all those different data streams and develop a platform for making them available, that was a core focus for our team of folks. So a key need then is to be able to seamlessly deliver all these different types of data products from both open ocean, estuarine, terrigenous sources, things like that, throughout the NANOOS domain, integrating across both cross-border, so working with folks up in Canada, as well as within adjacent regional ocean observing systems in the south and up in the Gulf of Alaska. And that's quite a challenge when you think about it, drawing together all these different types of data streams that are out there. NANOOS currently provides access to something on the order of 40 to 50 different types of variables. These are the different types of parameters, the waves, the winds, you name it. And in total, we're actually serving something on the order of 160 assets, and that includes both models as well as gliders and other in situ expand radar and things like that. So that's a tremendous suite of data variables and in situ assets that are available throughout the Pacific Northwest, all in one type of visualization system. The overall goal here, obviously, is to improve people's awareness in terms of situational awareness of conditions. That's obviously very important. The National Weather Service features very highly in this particular area. And it's critical to operations of many organizations that serve the public out there. So improving access and understanding of these different types of environmental conditions is also a critical element with what we try to do. And obviously, over the short to long term, building up the data streams, both short-term, long-term data series is absolutely paramount in terms of our understanding of the short to long-term changes that we witness along our coastline. So these are the overall goals towards ultimately improving our understanding of climate variability, safety, particularly in the Pacific Northwest with our extreme wave environment, operations in order to accomplish day-to-day activities, and then critically improving resource management for those state agencies and federal agencies that have important roles in these particular areas that hopefully when brought together will help in terms of overall regional productivity. So that's kind of the overall sort of visualization of where we were several years ago in terms of trying to integrate all these different types of data streams. The challenge obviously is, as we see in this room here today, is that clearly there are many, many different stakeholders out there, and every one of us have different needs and in terms of being able to access information of particular types. And that's quite a challenge for us as a team trying to figure out ways in which to actually make these data available. So through a lot of sort of visioning in the early years and discussions with multiple folks, we identified sort of critical elements that would actually form the backbone for the NANOOS visualization system. That is, we need to be able to seamlessly deliver information. It must be accurate. It must be of sufficient temporal, spatial resolution. to meet all those different user needs, and clearly, ultimately, the final step, meeting individual needs or agency needs. So within that sort of scheme of things, we identified sort of 4 key requirements: interoperability at both regional and national level scales, as well as at the global level. We must have a reliable mechanism for ingesting the suite of data that's out there, and then obviously developing the tools and mechanisms for making that available through models and applications and so on. And so based around that, we settled on essentially a very simple interface, a Google Maps type portal that revolves around really 3 core components. That is providing information on current conditions, making daily forecasts or forecasts out through several days available, and then obviously access to historical data. And it's the latter point there that is an area that we're actually working on as we move forward in time here on. Jan showed this image earlier, and it just highlights the ARCUs that we are developing within the Pacific Northwest. Obviously, there's a federal backbone here, which is based around the NDBC buoys, the National Ocean Service tide gauge stations that are strewn along our coastline. But there's also other parameters, the satellite-based imagery that's being collected for the Northwest. And so the challenge was actually how you go about integrating these widely disparate data sets and data streams into one mechanism. What we settled on was this really quite neat interface, the NANOOS visualization system, or NVS, and it's based around multiple assets with key icons indicating the types of instruments or payloads that are out there, ocean observing type ones, land-based systems and things like that. And there are multiple parameters that are being presented and made available through this type of system. I'm also showing as a backdrop here is a composite 1-month satellite imagery of water temperature over the past month here in the Pacific Northwest, and not surprisingly, it's all cold, so there's nothing terribly interesting to identify there. But it just highlights this capability of being able to visualize and overlay multiple types of data streams in one portal. And this was something clearly we never had before. So this is my one complicated slide. And I just put this up here just to actually highlight the complexity of the NVS system and the mechanisms that are being utilized to try and deliver information to your desktop anywhere in the country. And I mean anywhere in the country, whether you want to access it by mobile applications from smartphones or through web portals. But ultimately, it starts with the data assets that are out there in the ocean, delivering information via a harvester that goes out and sucks in that data, processes it based on a database, and then it's being delivered through a portal or through other types of delivery systems, and then ultimately reaching your smartphone or your desktop. So it's a very complicated process, and there's a lot of different elements that are coming into play through this process. And over the years, we've actually built in mechanisms that as one part of the system fails, someone is immediately notified through their cell phone that we can then go back and try and identify where that problem is. So there's some redundancy being built into the system as well to try to alleviate downtime, which periodically does happen. So within the NVS systems, you have, again, access to multiple information. Here's an example. This is showing WaveWatch 3 forecast, highlighting a very strong storm system. You have vector arrows showing directions of wave angles. These can be actually all individually turned on or off. You've got access to individual sensors. In this case here, this is a profiling buoy in Carr Inlet in Puget Sound here. And you have access to multiple variables, and in this case here, multiple depths. This is oxygen concentration at multiple depths at one particular location. And you can obviously access information over short time periods, 24 hours, 7 days, 30 days, and we're actually in the process of bringing out a 60-day time series very shortly. And the other element that will be arriving on the scene in the not too distant future is actually a time slider bar, which allows you to access a much longer time series, which may be of much greater use to folks. On the left here, you've got access to the in-situ assets. You've got cruise information, gliders. There's information about the status of the buoys here shown. For example, green indicates that the buoy is online. The shape of the pie there indicates when the last observation was taken, whether it's up to date. If the system is down for some reason, it turns red. You know, there's all these types of very useful information that's being available to folks in one location. I should also point out there's other critical things like linking directly to the specific providers of those buoys. You can click on that and it'll tell you who that person is or where that website is. There may be also information about, within the Details tab, about the status of that particular instrument, whether it's down or whether it's been updated or modified in some fashion. So there's a tremendous amount of information that's being disseminated through this particular portal. Another really neat component, here's an example. This is a federal asset. This is an NDBC buoy, Stonewall Banks buoy, located offshore from Newport on the central Oregon coast. Here we're actually integrating as a backdrop. This is the North American mesoscale model showing wind patterns across the Pacific Northwest. Wind speed vectors are shown and strength of the wind speeds are shown in the scale, bottom scale down here. At the particular buoy station, we're providing information about the current wave conditions at this particular, this is wind conditions at this particular locations. And this is actually in the comparator tab where we're actually overlaying information or model information for that particular site. And it's being updated on a daily basis as the model is improved, as more information is being provided there. We can see the level of skill of the model in terms of predicting the conditions out through several days, and it's changing obviously as the day goes by. So this is a pretty neat capability within the NVS system. You have access to other types of numerical models out there. There's a high-resolution Oregon State University WaveWatch model, which integrates much higher resolution bathymetry. There's the Pacific Basin WaveWatch model. It's operated by NOAA. So there's a lot of other types of data sets and variables that one can access through this particular system. Another element is actually, that presents challenges, obviously, is how you deal with taking casts of transit casts at particular locations. And this is based on PRISM cruises done in the Puget Sound region, developing in a longshore plot of changes in dissolved oxygen at depth at different locations. And you can see a particular area here down in the bottom of Hood Canal where very low oxygen levels are being achieved compared with out in the open Puget Sound region. So it's another tool within the NVS system that can be accessed by folks. So that's kind of where we're at the moment. Where we're going, and going back to my second slide, acknowledging the range of stakeholders that are out there, this obviously presents real problems for us because, you know, clearly NVS has reached a stage now where it's actually fairly complicated in terms of the amount of information that's available to folks. So the approach we're taking now is to try to develop more focused applications, and so we call these NVAPs or NANOOS visualization applications. And these are now being targeted at specific user groups. So for example, two NVAPs that are currently available is the Beach and Shoreline Mapping Portal, which I'll show a little bit about in a minute. And just recently we released in November the Pacific Northwest Tsunami Evacuation Zones, providing information about inundation from both local and distant tsunami events. Other portals that are actually in the making at the moment, we're looking at developing a Maritimes operations portal, a situational awareness where you actually will have current conditions of particular parameters that may be of interest. And then there are other more significant developments such as the integrated data access system, allowing for access to much longer time series of data, being able to customize and develop your own plots and comparisons of multiple parameters. And then also through a collaboration with the CMOP, Coastal Margin Centre. We're actually working with them through their Data Explorer to again allow for more simplified access of multiple variables and from multiple sites through a simple user-defined portal. Here's an example. One of the NVAPs, this is the beaches NVAP, showing, in this particular case, these are stations along the coast here and down in central Oregon, showing a time history of changes changes on the spit here, the current conditions in black, and eventually, you know, the indications are that this particular site down through here will probably breach, potentially opening up a hole into Netarts Bay, which could obviously have ramifications for example, the shellfish growing industry that's based in Netarts Bay. So these are the types of things that could be delivered as well as longer time series of this particular location. I just skipped over one slide. The other really neat portal that we've recently released is the tsunami evacuation zones. This is through a collaboration between my agency, Oregon Department of Geology, the Washington Department of Natural Resources, and NANOOS, where we're, as the agency tasked with developing evacuation zones, we're providing that information to NANOOS, and NANOOS is able to take that information and develop a really neat portal for allowing folks to actually figure out where they are and whether they're in a tsunami inundation zone and things like that. So here's an example. This is Cannon Beach. You can do a search by street address. You enter that in. Based on the shaded polygons, it tells you whether you're in an evacuation zone or an inundation zone associated with a local Cascadia, which is the bright yellow here, showing the maximum extent of inundation for this particular location versus a more distant tsunami that may inundate obviously a much smaller area. I point out that one of the neat things about this particular portal is that we're actually directly linked to the Alaska Tsunami Warning Center. And as information bulletins are released through them, it's automatically being updated on the NANOOS portal. And here's an example where we had an earthquake, 6.9 this morning, down near Vanuatu. Alaska Tsunami Warning Center issued a statement, information statement saying that basically everything's okay. There's no tsunami likely to be generated with this type of event. Everything's hunky-dory. So this is one of the other sort of neat mechanisms about this type of interface. We can actually bring in lots of different types of overlays, identifying critical facilities. We can identify things like bridges. If you actually gloss over that little point there, it'll tell you that be careful when you're planning your evacuation route. This bridge could be damaged in an earthquake. You know, things like that people would not normally think about, but we can actually provide that information through this type of portal. Other types of information that's listed there, I mean, there's a really wide, a huge amount of information about preparation, procedures for evacuation, how to respond in local and distant earthquake scenarios, and information about where to go. So there's a tremendous amount of information here which is now available or more easily available to the public at large. Significant amount of development and time and effort has also been directed at developing applications that are going to be able to or are available for smartphones. It's very clear that smartphone technology is really probably the way of the future, and increasingly a lot of the information that we're seeing on desktop type applications will become more available through these types of smartphone apps. So NANOOS released an NVS mobile application, basically analogous to the main portal, which has all those in situ assets. You're able to obtain direct information about waves, tides, you name it, at any point along the coast or wherever you want to be. And so you can get access to that information very easily. In November, we released the Tsunami Northwest evacuation app for iPhones, and then in January, just a few weeks ago, we released a similar version for the Android market. And so both of these are now available. It basically emulates the tsunami portal. It brings in that added advantage that when you're out there, you can locate yourself immediately. You can tell whether you're in the inundation zone or not, and you can obviously plan accordingly. I was saying to my boss earlier, it's quite thought-provoking when you're actually standing out on a spit there and you locate yourself on using that tsunami portal, and you suddenly realize the area that you're in and the area behind you that's going to be inundated. It's actually a real wake-up call, and it makes you think about where you need to go in the advent of such an emergency. So, you know, it's very clear that this type of technology will play an increasingly more important role in all our lives. And I'll just finish up by saying that within this portal, it has, you know, essentially every capability that you see within the actual main website is being emulated here. You can control elements of, you know, in terms of backdrops. You can control the degree of shading or transparency, things like that. You've got access to brochures, the PDFs themselves that are produced by the state agencies responsible for that. You can turn on and off markers and all that sort of stuff. So there's a lot of features within this particular tool that you can manipulate and control and utilize. So one of the great things to see about a slide like this, which is attempting to capture the usage trends of the NANOOS portal and website over the past several years, it's great to see that we're indeed growing. I'll point out that these black lines are sort of averages for those years there. And clearly you see a lot of spikes as incidents happen along our coastline, and it generates interest. And here's an example. March 11th, we saw a very dramatic rise in the number of people wanting to access the NANOOS NVS site in terms of trying to find out information, whether it be information on water levels or the tsunami inundation zones or things like that. But the neat thing to see is that over time, we actually are growing. We're growing slowly, but it's happening, and it's very exciting to see, certainly in the last year or so, you know, a significant uptake in interest in the NANOOS system. So it's very encouraging in that respect. And I'll end there. Just last comment. I mean, I think we've done a remarkable job in a very short period of time. I'm excited to see some of the potential future technologies that NANOOS can actually help and hope to utilize better. And I think certainly providing we remain integrated and are able to maximize that to the best of our abilities, I see some exciting new opportunities and products for the NANOOS region as a whole. Thank you.
Thank you.